Two fingers overlapped, 'cause I can never keep my word, and I share with the undeserved for some cheap acceptance in return. The water will shape the sides, and I'll walk with my head held high, and when it all comes crashing in, it will be worth it if I'm still breathing. If actions speak louder than words, I'm the most deafening noise you've heard. I'll be that ringing in your ears that will stick around for years.
Right. Today we're going to talk about the atom. This is a helium atom. The neutron, the nucleus of the atom, is composed of positive protons and neutrons, which are neutral. Outside you have electrons, which have a negative charge, so the atom becomes stable and without charge. Now I know you may be thinking, how do the protons here stay together when they have the same charge, so they should repel? But there's a strong nuclear force that can only exist at really small distances, such as the nucleus of an atom, which can balance out the repulsive force. This is why on larger atoms, such as uranium, they are less stable, as the forces of repulsion are overpowering the strong nuclear force, causing it to decay. Now, the model of the atom has not always been like this one I showed you earlier. People such as Democritus, who lived in ancient Greek times, thought that smooth objects were made of smooth atoms and rough objects were made of rough atoms. Obviously we know that's complete bullshit. So now we're going to look at a timeline of the scientists who helped create the model of the atom that we know today. Let's explore.
These wounds are still fucking bleeding!
In 1897, J.J. Thomson was credited with discovering electrons using properties of cathode rays, and he also invented the mass spectrometer. He was awarded the Nobel Prize for the discovery of an electron and for his work on the conclusion of electricity and gases.
Are you still filming?
Oh! Another opponent is just Ernest Rutherford. Ernest Rutherford is known for his golf foil experiment. You find alpha particles at a sheet of golf. Most of the particles went straight through, but some of the particles bounced back, which disproved J.J. Thomson's early model of the plum pudding. From this, he found out that atoms have a nucleus, which is very small and dense, containing the positive charge of most of the atom's mass. He also concluded that an atom consists of mostly empty space, and that electrons are attracted to the nucleus, but they are not inside it, but remain outside in shells. According to Chadwick, atoms also contain neutral particles, which help make up the mass. This was the discovery of the neutron. In 1704, Isaac Newton, who I'm sure you've all heard of, proposed a mechanical universe with small solid masses in motion. Then, 99 years later, in 1803, John Dalton proposed an atomic theory with spherical solid atoms, which are based upon measurable properties of mass. Then, in 1894, G.J. Stoney proposed that electricity was made of discrete negative particles that he called electrons. Then, in 1897, J.J. Thomson, who we've already discussed, used a CRT to experiment and determine the charge-to-mass ratio of an electron, which turned out to be 1.759 times 10 to the 8 coulombs per gram. Then he studied canal rays, and they were found to be associated with the proton H+. Right, in 1905, a man called Albert Einstein, who you all know because do physics and shit, came up with the equation E equals mc squared. In 1911, Ernest Rutherford used alpha particles as atomic bullets to probe the atoms in a thin piece of gold foil. He established that the nucleus was very dense, very small and positively charged. He also assumed that electrons rotated on the outside of the nucleus. This is a model of the scattering experiment that he did. In 1932, James Chadwick was able to discover the neutron, which was also in the nucleus, which helped contribute to its mass. This is pretty much all we've told you. If you want to learn more, just go and Google it.